Okay, in this video we're going to show you the difference between a current relay and a solid state relay and how the difference in operation. Now, a current relay or an amperage relay, I'm going to show you how it works. You have this coil here and you have your hot wire going into your coil. So when the power goes through the coil, it creates a magnetic field, and there's a little plunger in here that gets pushed up or drawn up by the magnetic field. There you go. So here's your coil right here, your run winding and your hot wire coming in. So when that coil is energized, creates a magnetic field. That plunger in here, which is right here, here's your start winding. So when that plunger comes up, it makes a connection between the hot lead coming in and the start winding. And this plunger has little contacts. See these little contacts on here that transfer the power. As soon as the compressor picks up 75% of its speed, the current drops, the amperage drops, and that plunger drops. And then it takes the start winding out of the circuit. So if you shake this, you can hear the plunger going up and down. If I turn it upside down and put a continuity meter on there, you'll see the difference. Now let me try to put this back together so I can show you what I mean. Now, solid state relays are okay. The problem with the solid state relays is that they never really take the start winding out of the circuit, so it creates a little extra heat. And I haven't seen any factory service organizations, Sub-Zero especially, that uses solid state relays, even though we use them. Also, this is your overload. So your power goes through here, and if the compressor is drawing in too much amperage, or if it's seized, or if it gets too hot, there's a little bimetal in here that bends this and causes this to open and takes the compressor out of the circuit. So here's my continuity meter, and so I want to show you, here's your hot wire coming in, your lead. There's your coil. Okay. Now, should not be any power at the start. This is the start winding. But when the plunger comes up, see the meter there? As soon as it's taken out of the circuit, start winding is taken out of the circuit. And that's how current relays work. So let's continue on. I've taken this solid state relay apart. I want to show you how this works. So now we got the solid state relay hooked up, compressor's running, and as you can see, it's basically just an overload on there, just like this. Here's your overload. That's an overload, and they have this little disc in there. Now watch what happens when we go from common or hot to the run winding. We got power, see? So power's going through the disc, going into the run winding, but look at this. You got a voltage there, which means that start winding is never really taken out of the circuit. And that's what the difference between an amperage relay and a solid state relay is. And normally these things, I've seen some of these things glow red. They've changed it, and when they first came out, I want to say maybe in the early 70s possibly, Supco came out with the solid state relays, and we started using them. We were having problems with compressors burning out because the start winding wasn't taken out of the circuit all the way, and so of course it overheated the compressor and it went down. But they made some improvements to it, and that's what it looks like inside. So let me pull this plug out. And I don't want to touch this because it's very hot. But see, it's just basically an overload. And there's your There's your disc. That's all happens inside. There's no moving parts. It's just that when you first turn it on, the power goes through the start winding, gets the compressor up and running. When it reaches 75% of its speed, the amperage draws down. There's a disc in here that gets red hot, which reduces the resistance and takes the start winding out of the circuit. But as you can see, the start winding isn't taken totally out of the circuit. That's the difference between a current relay and a solid state relay. Okay, thanks for watching. One more thing I want to mention here is the pin configuration. When the center pin is on the top, that's the common pin. The run winding is on the right. Start winding is on the left. So I always remember red, right, return. You know, if you're a sailor, you know what that means. If the center pin is down on the bottom, then it's inverted, and the start winding will be up here and the run winding will be there. So when you hook up a relay, you know what you're doing. And of course, a magnetic relay or a current relay is going to be a little different configuration because it's flipped. But a little tidbit of information in case you need it. See you next time.